Hello, everyone. Welcome to Quiet on Set, building an on-air sign with open source technologies. And let's welcome to the stage our speaker for this session, Danica Fine from Snowflake and much more. Danica,
Hey
the
everyone,
floor is
thank you so
yours,
much.
and I'm coming off stage.
Great. Hey everyone, thanks for joining my session today. I'm really excited to share with you. My name is Danica Fine. I lead open source developer relations at Snowflake, which means that I get the privilege of talking about a lot of different open source technologies. My two main ones are Apache Iceberg and Apache Polaris, which we will get to later in this session. But prior to that, I was in developer advocacy in the streaming space, so Apache Kafka and Apache Flink. And so this session is going to combine a lot of those technologies together, and we're going to build something useful. So you may have seen me give a couple talks about IoT and things that I've been building. So this is one of those fun sessions. My main requirement when I'm building an IoT project is that it has to solve an actual real problem in my life. And in this case, my motivation for building an on-air sign is that I sometimes work from home, as I'm sure many of you do. But when I'm working from home, it's also usually the case that my partner is working from home. And we still struggle with, walking in on each other's meetings and distracting each other. So I feel that I needed to build an on-air sign to help indicate when people should not come into my office. For example, when I'm giving a conference talk. And so that's sort of the motivation behind this project. So what I needed to do, I needed a way to connect what was going on my computer. So meaning camera and recording usage, as well as Zoom meeting activity. And I wanted to connect that with some sort of indicator light, right? An on-air sign in this case. And ideally, I'm capturing this information from my computer in real time so that I can update that on-air sign as quickly as possible. And there's a lot of different technologies that we can use to make this connection between my computer and the on-air sign, but I am going to choose Apache Kafka and as this event streaming component. And I'm going to feed this my camera and Zoom event information into Kafka and let that power the on-air sign. As I said, there's a lot of different technologies that we can use for this piece, but the benefit I think of using Kafka over some other messaging systems is really the persistence of the data. So while I don't necessarily need to keep my data in Kafka for streaming beyond powering this sign, it doesn't mean that I shouldn't still do something with that data later on. So we're going to take advantage of the fact that we're persisting this data, do a bit of stream processing with Apache Flink, and we're going to write that data downstream to Iceberg tables for long-term storage and more interesting analytics down the line. So that's the plan. That's our motivation here. Let's go ahead and build this physical system because I'm sure that's what most of you are here for. So as I mentioned, I've built quite a few IoT projects in my time. And when I look back at all of them, I think all things considered, this one was pretty simple to pull together. And I'm going to pretend that all of you are here because you want to actually build the system for yourself. So I'm going to do my best to outline all the supplies that you need to actually pull this together. So the first thing, the most important thing, obviously, is a Raspberry Pi. You can technically build this project with an Arduino. I am not the right person to ask about it. So we're going to pretend everybody's using a Raspberry Pi. Next thing, the actual on-air sign. We're going to use an RGB LED matrix. I picked up a 64 by 64 pixel sign. This is a sign, and this is going to serve as our on-air sign. I know it's a little bit rudimentary, but I wanted a lot of flexibility to do whatever I wanted with this. So it's really open-ended. So I chose the most basic sort of system I could to pull this together. And then finally, another critical piece is a matrix hat. This is going to help us to actually interface with the LED matrix. Because when you think about it, this matrix is a lot of components. It's 64 by 64 pixels. So that matrix hat is going to help us actually interface with those individual components. It's going to provide a better interface for us to actually update them. And it's also going to provide additional power to that matrix. So it's pretty important to have, especially for the size of matrix that I have. So this list, not exhaustive. If you've done any sort of IoT projects, you know that there's always some extra bits and bobbles and cables and connectors that you need. Some of them are pictured here, especially with that the LED matrix itself. The good news is that if you're new to IoT, if you're buying from a retailer like Adafruit or DigiKey, you're going to find all the necessary components that you need directly linked to these three things. So that means that this is a good project, I think, to get started with IoT, because you're not going to have to look too far for the things that you need. So it's a good starting project, in my opinion. If you ignore the next very critical step, I'm going to do a little bit of hand waving here because you need to do some soldering. But I think this is a great opportunity for all of us to purchase a soldering iron if you don't already have one. Um, there is one necessary connector that you have to actually solder. I tried to avoid it. You have to do it. I wanted this to be a plug and play, but you do need a soldering iron. All right. And so here, if you didn't believe me, here we did the thing. I built it. This is my very messy workstation with all the components immediately post soldering. So the LED matrix, which was I thought was really cool, is that when you're actually installing the repository on the Raspberry Pi, the driver comes with some very handy demos that you can run once everything has been plugged in, and just use this as a sanity check to make sure that everything's working as it should be. And so when I transitioned from just building software applications into IoT things, it was a pretty big hurdle in my mind to think about debugging not just a software problem, but also incorporating hardware. So by having these handy demos already ready to go meant that I didn't have to think about whether I had done all the connectors properly, or whether the demo's just not working because I have a software bug, right? So it was really nice to have that in there just to make sure everything was working properly. And so with the sign actually working, I could go ahead and install it where I wanted it to be. And you're all probably going to be a little bit disappointed. I'm currently in the process of moving things around, but at the time of actually building this slide deck, I didn't actually mount the sign outside my office, which I think defeats the purpose of the actual project, but I promise I have a couple things that make it still worthwhile. But for the time being, for development purposes, I did have the on-air sign living on my office shelf. It is no longer behind me because I'm working on the actual more permanent solution right now, which is to mount it outside my door. It's taken a little bit of time, as a lot of house projects do. But yeah, for the time being, I did have it in my office shelf and it looked pretty cool. So with this sign actually installed where it needed to be, I could go ahead and focus on powering the sign and actually sending events to it, and making it do the thing that it needs to do. So first things first, I did mention way out in the beginning that I would be using Apache Kafka for the real-time event data here. But before I get too far into it, I want to make sure that everybody knows what Kafka actually is. And the easiest description is that it is a distributed event streaming platform. So in this case, we have events that for this project are camera and meeting information. And these events are going to be produced to and stored within specific partitions of data sets called Kafka topics. Within those partitions, the events are going to be ordered by their timestamps. Once the data is stored in these topics, any number of downstream consumers can come along and read from those partitions in a way that doesn't affect other consumers. So essentially, Kafka lets us build decoupled pub subsystems, but it also lets us build systems that can take advantage of the fact that there will probably be multiple partitions in that Kafka topic. And we can then parallelize the processing of the data from those partitions, and scale out our applications down the line in a very efficient way. Now, Kafka is a distributed system. You have to run a Kafka cluster somewhere. I'm going to do a little bit of hand waving here. It's left as an exercise to the reader. But know that for at-home use cases, you can run Kafka in a couple Docker containers on your laptop. You can also build a Kafka cluster over a couple Raspberry Pis, which is a work in progress for me right now. But that is the dream. That's what I want to get to. If you're hands off, there's a couple free trial services that you can play around with, or run it on S3. But once you have your Kafka cluster running somewhere, we can start thinking about generating this data and capturing and creating that information in Kafka topics to store it in. So the first thing we have is our camera activity. So for this use case, for my camera activity, I wanted to know whether my camera was on or off. That was the biggest thing. But it could also be useful from an analytics standpoint to know what application is actually using the camera, right? Is it Zoom? Is it some sort of application for presenting at a virtual conference? Is it Google Meet? Is it recording software? I want to be able to accommodate that to the best of my ability. So that's why I have this application ID in there as well. Now, beyond that, we have our Zoom usage. For about 99% of my work calls within Snowflake, we use Zoom. So I figured it made sense to specifically capture Zoom information as opposed to making it generic and capturing Google Meet or Teams or what have you. But I can certainly extend this and make this generic later on or build it out with a couple different topics there with meeting timestamp or meeting status. But for now, we're just going to focus on Zoom. So we have our camera data, our Zoom data. For each of these, I'm going to create a Kafka topic. I'm going to create them with, for now, one partition each, and I'm going to set the retention time to be just 1 week. I really wanted to keep this, the data set, limit the data set within Kafka itself to kind of be a little bit ephemeral within that 1 week. But you do have flexibility to change this later on, so keep that in mind. So once both of these Kafka topics were created, I could then focus on actually capturing that data and producing it into those topics. For the camera events, first things first, I actually had a lot of fun trying to figure out how to capture camera activity on my computer, especially since I have the built-in camera that I'm presenting on now, and I also have an external one that I use for certain recordings that I'm working on getting set up more robustly. So it wasn't just enough to track the information from the FaceTime HD camera or whatever it's called on Mac. I wanted my solution to pick up any of the cameras that I could be using. So in the end, I decided that I could leverage the built-in macOS log stream to monitor camera activity. And if you haven't used this before, and I've actually learned that a lot of people don't know about this, but Macs have built-in unified logging. So with log stream command from the CLI, you can filter for events that have specific keywords. In this case, I found that the phrase AV capture session is used every time that a camera status has changed. And it also displays the application that is using that camera. So knowing that, I can take that command. I could write a Python script to execute that log stream using subprocess, and then I could and during that, all of these logs are going to be pushed to me, and I can extract the relevant information from the log lines that I'm capturing and package it according to that schema that we created and produce it to Kafka. Okay. An important thing here is that this is event driven, right? As soon as something happens with my camera on my MacBook, that log line is generated. I'm monitoring that log stream and I can do something with that information and write it directly into Kafka. So that is as real time, as event driven as it gets. I'm calling this out because for my Zoom information, it wasn't as real time. Okay. Because of my limitations just with my IT department and what I'm actually allowed to do with APIs on my computer, I couldn't find an easy, clean way to capture Zoom events. Now, Zoom does have an API that you can take advantage of, but for me, I couldn't do that. So I had to be a little bit more proactive, a little hacky to fetch the Zoom status to see if I'm in a meeting or not. I am fully admitting it's a bit of a hack, but hacks work. So basically, to figure out if I was on a Zoom call, I found out that I could check how many ports Zoom had open at any given point in time. This was a good enough proxy in my case to figure out if I'm in a meeting or not. So I'm going to take this command, run it at some predetermined interval. I think right now I have it set to 1 second. And I'm going to execute that again in a Python script using subprocess, and I can extract the data to write that into Kafka as my Zoom status. If the result of the above command was 0, it meant that Zoom could be running, but it's not actively in a meeting. If it's anything other than 0, it means that, all right, we have a meeting running, and I can actually send that status into my Kafka topic. So again, packaging it according to that schema and writing it then into Kafka. Now, this next bit, definitely not glamorous, but we had to make it real, right? I have these two scripts that are capturing my camera information, my Zoom information. I need them to be long living. So I needed to schedule this script to be executed on startup or when I log in. It really wasn't that bad. So you can take whatever script you wrote. In my case, I have camera monitor and Zoom monitor, Pi, and you can create a plist file, a property list file. And so 2 things to note, when you're creating this file, first of all, you need to make sure all the right permissions are set for your script, making sure it's executable by another user. And if you have any relative paths, maybe for a config file or log files, which I advise everyone to do, you need to set those to absolute paths to make sure that everything is runnable. So within the plist file, I'm going to specify keep this program alive. So this means that anytime I log into my machine, this script is going to be booted up and it's going to be brought up again, even if it dies. So that's why it's really important that you make sure you have the correct logging set so that you can check in and make sure that everything's running as it should be. So this plist file needs to be saved in the launch agents directory on your MacBook. And then you can use launch control within the command line to load it and then start it for that first time. So when those scripts are up and running, I then see there's a sample of some of the data that I would see in my Kafka topic. Great, I'm excited. It does the thing, all right? So that data is in Kafka, but now we need to actually drive the on-air sign, use that information within the Raspberry Pi. So here I'm going to write yet another Python script. We're going to set up 2 Kafka consumers to consume from each of the Zoom and the camera activity topics. Within each iteration of a while loop, I'm going to attempt to consume from each of these topics and extract the status from those Kafka messages. I return a Boolean is on, which is true if the sign should be on from the Zoom or camera standpoint. And you'll also see that I'm passing in the past iteration result for is on, just in case no new events have come in that particular loop. Okay, so I have 2 functions that are doing this, one for the camera events and one for the Zoom events. So from there, I can take those 2 Booleans and combine them and decide ultimately if that light should be on or not. Missing from this code snippet is a bit of boilerplate code to set up the LED matrix, basically, establish it, preparing the canvas for it to display text. But once I check the Booleans, I can go ahead and display on air or otherwise, leave it blank or display something fun. Something I wanted to like call out here with this particular LED matrix is that there's totally a learning curve. It has a pretty nice Python wrapper that does some nice graphics functions. You can draw lines and text. Wow. But when you compare it to other technologies that you may have used for front end things, this is very different. So it takes some getting used to. So if you end up building something like this, give yourself some, be patient with yourself. But yeah, so here, once this is up and running, it works. We launched the script on the Raspberry Pi. I set up everything with my long living scripts on my MacBook. And within a second of turning on my camera or hopping on Zoom, this sign is eliminated, as it should be. So at this point, we have a working model. I'm collecting this camera meeting information. It's driving the sign. We've accomplished the basics that we set out to accomplish. But can we do more? The answer is always yes. So to remind you of the ultimate plan, we have done these bits, right? We have driven the sign with real-time data from my machine, but we can make it more interesting. If you haven't dealt with Kafka before, Kafka is great for a lot of things, especially when we need to build event-driven reactive pipelines, which we have already done. But the reality is that my Zoom information, my camera events are effectively useless as streamed data beyond a second or so. Right? The TTL on the usefulness of this data is so low. If I drop an event in there and it doesn't power the sign, it's fine. We'll survive. But just because I don't need that data for streaming beyond a couple seconds doesn't mean that data isn't useful for something else. So we'll take those events, do a bit of stream processing, and we want to offboard them to another system to aggregate that for long-term analytics. And we're going to do that with Iceberg tables. So at this point, you might be asking yourself, I'm here for an on-air sign. Why am I bothering with analytics at all? That is a great question that I will answer with another question. So think about how many of you use Google Calendar? Probably all of you, right? And maybe if you've taken time to look into Google Calendar a little bit, it has a very fun, mildly stressful feature called Time Insights. I have a love-hate relationship with it. It tells you how many hours you spend in meetings and how many hours you spend in different types of meetings. It gives you a breakdown of the different types. It aggregates it across different time periods. It's pretty cool. This is basically something I could recreate with the information I have that I'm collecting. Okay. I'm already collecting how much time I'm spending on calls. So I could recreate this feature. And as a bonus, I have an added dimension of my camera data. So I can figure out if I'm just recording content, which I do a lot for my job, and have this factored into my time breakdown, which I thought would be fun. So the goal here is then to offboard our Kafka data so that we can do analysis like this in the future and play around with it. And we're going to do this with Apache Iceberg. So I wanted to take a second to introduce everybody to this technology. So Iceberg, it's an open table format. It's purpose built to handle large scale data sets in a data lake. It is not a database. It is a specification on how you should organize files in your data lake, in object storage, in order to better coordinate accessing and updating those data sets. Okay. And it does this by adding a layer of metadata on top of those data files. So you can think about Iceberg as the combination of a data lake and a data warehouse. You get the best of both worlds, honestly. And I really want to drive this home. I think that Iceberg is a really great add on to event based Kafka architectures because you get a cheaper way to sort of maintain that data in the long term for fast and efficient analytics. And it integrates pretty nicely, as we'll see, with the real time stack. Okay, so I'm going to go over this kind of quickly, but I wanted to give everybody an idea of Iceberg's architecture. So you'll see we have our data files, the actual row-wise data that we want to store in our Iceberg table. But we have this component of metadata. Okay, and an important thing to note here is that Iceberg operating properly does not rely at all on a directory structure. So we're not coordinating the metadata in nested directories. So we're really relying on the pointers between all these files in order to make Iceberg work, which is a benefit if you think about other systems that have other systems that rely on directory structures, some of the limitations that they have. Okay, so the whole point of this metadata layer is to point to subsets of data files and maintain statistics on each of these data files, so we know exactly what's within all of our data files. And these are going to roll up to each subsequent layer of our metadata layer and make it so that we can ignore files that aren't relevant to us when we're trying to query it. Okay, so the whole point of Iceberg is to efficiently query your data and make that process as easy as possible. Okay. But there's one more component to Iceberg that is absolutely critical, and that is the catalog here. The catalog is going to keep track of individual tables and maintain references to that latest metadata file as it evolves over time. And there's a lot of different catalog implementations that you can use, but we're going to use Apache Polaris. Okay, so those are the high level components of Iceberg, metadata, our catalog, but Iceberg is just a format for storing our data in. So to interact with Iceberg tables, you need to work with some sort of compute engine or query engine. The Iceberg project maintains built-in implementations of Apache Flink and Apache Spark, but there's a lot of other implementations that are Iceberg compatible. This is not exhaustive, but it's important to know that the Iceberg compatible implementations are constantly growing and evolving. And this is great for you because this means that once your data is in Iceberg, you can pick and choose and play around with as many of these different compute engines as you want for your particular use case. Okay, so the name of the game is interoperability, and that's what we like. So Iceberg, I think it's going to be a great next step where we should offboard our data. So now we need to focus on moving the data from Kafka into Iceberg. So there's a couple different main ways that you can do this. You can use Spark, Flink, and Kafka Connect. What you choose for your real life workload is going to depend on a lot of different factors. What your team is familiar with, what your SLAs are, what sort of Iceberg features you're trying to get out of it. But for my pipeline, we're going to use Flink. If you haven't heard of Flink before, it is a distributed processing framework. It is very good at both batch and stream processing, and it's really good at integrating with Kafka. Okay, which is the main reason why I wanted to use it here. It also has a lot of different APIs depending on what you need for your particular use case. And one of those APIs is a SQL wrapper, which is what we're going to use to both read the data from Kafka and write to our Iceberg tables. So starting, to kick things off, we need to read from our camera activity topic. And within FlinkSQL, it's as simple as creating a table with a Kafka source. So you're going to do that with the connector property that you see on line 8. We refer to the specific Kafka topic on line 9. And from there, there's a couple other boilerplate configurations that we need for any Kafka consuming application. You need a group ID, the brokers, your schema registry, and a couple more in there. But from there, we're going to define the table much like we would any other table in SQL. We specify the fields, the types. And then one other thing I wanted to call out is that I'm also, you'll see as I'm loading in these fields, I'm evaluating an expression as I'm reading in this data. So on line 6, you'll see that I'm creating a temporary partition timestamp field on the day of the data that I'm capturing. And I'm going to use this field, this as the field that I'm going to partition our data in when I write it into Iceberg. I wanted to call this out because partitioning your data in Iceberg is a great best practice, especially if you want more efficient reads later on. And it made sense to me to partition on the timestamp here. And we're going to do a similar thing for our Zoom activity topic as well. And then from there, our Kafka data is loaded into tables in FlinkSQL. But now we need to prepare Flink to write to our Iceberg tables, which means it needs to connect with S3, and it also needs to connect with our catalog. So remember, that's an important component of Iceberg. So outside of Flink on my machine, I have Apache Polaris running. So we need to connect to Polaris. So within Polaris, I've created a catalog, I've created a user, I've given myself some credentials so that I can work with that catalog, and I have permissions to work with an Iceberg. And so this statement right here is where I am giving Flink access to that catalog. I'm allowing myself to create those tables within Polaris, Iceberg tables. And so from there, we create the camera activity and Zoom activity tables within the Polaris catalog as well. And also note here that I'm partitioning by that partition timestamp field that we created when we loaded that data initially. And then to populate the new Iceberg tables, we simply select from the Kafka tables and insert everything. So this is just one instance of launching a Flink SQL client and doing this operation, but you can imagine this being a scheduled task that runs every day or so. And then from there, we have the data in S3, in Parquet files that we can then work with any Iceberg compatible engine. So I know I am definitely out of time here. So I wanted to give you an idea of what's currently being worked on in this project, because I've kind of left this in a little bit of an open end state for all of you to play around with. But I wanted to share some of my backlog and what I'm currently playing around with here. So less glamorous is productionalizing everything, moving everything to AWS, so I don't have to think about anything running on my machine directly. I am moving the Kafka data to Iceberg using Flink every week, but I have yet to schedule that officially. So that's an important part that's on my backlog. And then playing around with the meeting trends and actually, building out the Flink SQL pipeline, aligning my Kafka data across these topics. This is where Flink is really going to shine, to actually play around with the stream processing component and do more of that ahead of moving it to Iceberg. So. And then as a fun thing, I have a stretch goal of building out an application like a chatbot so that I can play around with the data without actually relying on the sign, which I think is a fun extra use case here. But yeah, so if you want to see more of what's happening with this project, feel free to follow me. I've dropped my link tree in the resources here in the chat, but I also wanted to provide you with link tree here. And so I know I'm absolutely out of time here, but I want to thank everybody for coming along and seeing what I've built. And I do want to remind you all of what we actually accomplished here. I know this is kind of a fun, maybe ridiculous use case, but I think all of these ridiculous use cases actually teach us something. All right. So the way that I've set this up of generating the data to Kafka and then offboarding it for stream processing into Iceberg, this is a very real pipeline that a lot of very real companies are setting up every day. And so while this was a fun thing that we pulled together for an at-home use case, I just want to remind everybody that playing around with these technologies and being familiar with them is actually extremely useful, I think, to every engineer, every software developer. So I hope that you will challenge yourself to build something similar, and let me know if you have any questions. So again, thank you all. I appreciate you all being here today, and have a good rest of your PyData Global.